Hello everyone. I hope everybody doing good. So today's session we will see a kind of Delta Lake concept in Microsoft Azure Fabric. So in the previous sessions we just discussed about Microsoft Fabric Lakehouse, and then after the Lakehouse how to use Apache Spark, and how to create the table using Apache Spark, and how to create the data frame, and whatever the Spark properties we can able to use, we explained in the previous session. I request you guys to go through my previous sessions, so that case you will understand what is Lakehouse and what is Spark, how to use in Microsoft Fabric. So today's session we will discuss about Delta Lake concept. So this is one of the important concept in data warehouse technologies, particularly in previous. If you guys have the experience with the Azure Databricks earlier, even Databricks, they implemented, like they have implemented one of the like important topic as Delta Lake concepts. So that is mainly kind of version maintenance, and it's kind of optimized and efficient way to maintain the tables and data. Let's get into the session. Let's talk about what is Delta Lake and how to create the Delta Lake tables, and what are the functionalities available, all those things. Let me go to the material here. Yeah, so this is already I watched this documents. That's what it's showing like this. So let's go here, and tables in, yeah, tables in Microsoft Fabric Lakehouse are based on the data lake storage format commonly used Apache Spark. By using enhanced capillary data lakes, you can create advanced analytical solution. So what they are saying, like maintaining the table with the delta lake concept, it is one of the efficient way, and it is, you can create advanced analytics options using delta lake concepts, and particularly it is supporting streaming as well. Okay, so this theoretical document, we just going to understand about delta lake table in Microsoft Fabric, how to create it, and how to query using Spark, and how to so use for streaming purpose. Okay, so the prerequisite, they are saying like you should be familiar with Microsoft Fabric Lakehouse and Apache Spark. So in the previous two session we covered that only, like what is a lakehouse, and how to build the lakehouse in Azure Fabric, and then how to use Apache Spark and lakehouse. So if you refer those video, it will be very easy you to understand this model. Okay, let me go to introduction. Yeah, tables in Microsoft Fabric Lakehouse are based on the Linux Foundation Delta Lake table format commonly used in Apache Spark. Delta Lake is an open source storage layer for Spark that enables relations database capabilities for batch and streaming data. By using Delta Lake, you can implement Lakehouse architecture to support SQL-based manipulation semantic in Spark with support for transaction and schema enforcement. The result in the analytical data storage that offer many of the advantages of relational database system with the flexibility of data file storage in the Delta Lake. While you don't need to work directly with the Delta Lake API in order to use tables in Fabric Lakehouse, and understanding the Delta Lake metastore architecture, familiar with some of the more specialized Delta type operation can greatly expand your ability to build advanced analytics solution on Microsoft Fabric. So what they're trying to say here, using Microsoft Azure Fabric, we are going to create the Delta Lake tables. Then we will store the data into data lake tables, so that data lake concept, it will be helpful you to build advanced analytical solution. That's what they are trying to know describe here. So when we go for the practical session, I will tell you like how to create the delta label, and what are all the properties you need to use, and what are the properties are available, and how to create the streaming table, and what are the now how to use that table for Spark directly, Spark SQL or Spark data frame or any Spark context. Okay, how to deal with, how to interact with Delta Lake using Spark concept. So those examples we'll see. So that's what they're trying to say. This is a Linux based Delta Lake concept format, and it is kind of, anyhow, the people already know Spark is open source platform. So it is supporting streaming data as well. Okay. Let's go back and come to the explanation, understanding of the Delta Lake. Yeah, Delta Lake is an open source storage layer that adds relational database semantic to Spark based data lake processing table in Microsoft Fabric Lake user data table, which is significant by the triangle delta icon on the table in the lakehouse user interface. Yeah, so as we discussed, like Delta Lake is an open source storage layer that add relational database semantic to Spark based lake processing. So which is signified by the triangle delta icon on tables in the lakehouse. So whatever the data table, whatever the table we are creating in Azure Data Lake storage, lakehouse on Azure Fabric Lakehouse storage, that will create with this icon, okay, triangle icon. That means that is a data lake, delta tables. That's what they are trying to mention here. So already we created the using Spark, we created the tables and we created the some queries to read the data. So the same things they are trying to explain here. So it is supporting kind of no yeah, it is kind of it will build the relational database semantic layer for Spark. So that means using relational database, what we can do, we can create the tables, and in the tables we have attributes and tables. So same things we can support, same things we can able to create using Delta Lake concept in Delta Lake or Azure Fabric Lakehouse. So when you create the tables, you will get create the file. One is two files you will get create. One is Circuit file, like kind of Circuit format. The Spark 0. This is the data file, and then another one is a delta layer, delta underscore log folder. So this is nothing but whatever the transaction and whatever the changes we are doing in the delta lake table, that will save as a log. So if you using the referring this log, you can able to revert your table whatever the stage you want. That means like it will maintain the versions in the log detail. You can revert those version of the table. So that case you don't need to recreate the table, or you don't need to drop the table under kind of need to take the backup also. So whatever individual versions the data lake table have. So for example, first time you are inserting the data into the table, that will consider as a one version. After that you are updating the table, then it will consider as a version 2. After that maybe you are deleting some data, uh, the table will maintain as a third version of the table. So if I suppose in the future if you want to revert the your first version, then you can revert the first version. So that case whatever you deleted, whatever you are updated, it will be gone. What is the status in the originally in the first version, it will get revert. So that's the purpose we are using delta log here. So that is a built-in feature. Once you create a table, automatically this will get created in the backend, the storage layer. So this is what the same story in SQL database. Whatever we are seeing, ACID properties, data versioning, and support batch and streaming data, standard format and interoperability. So relational database that support query, data and modification. So what we will do in normal SQL server using database, relational database tables, you can create the table, you can query the table, you can do the any modification on the table. So the same functionality is supporting in Delta Lake concept using in the Azure Map, Azure Fabric Lakehouse. That's what they are using Apache Spark. It is supporting. That's what they are mentioning here, and then it support for ACID transaction. So it is nothing but in the SQL server we used to call transaction completer, like kind of atomicity, consistency, isolation, and durability. So that means it's nothing but like it will maintain the transaction properly. For example, the table, one table you created, once you created the table, one person trying to insert the data to the table, another person trying to update the data into the same table, and another person trying to delete the data from the same table. So what will happen if the table does not support ACID transactions? So the table would get collapsed. So that means like it will get deadlock, and it will get corrupted. The table get corrupted. So if the any technologies or any concept supporting ACID transactions, particularly in SQL Server, so it will maintaining the thread, and it will do the process step by step. So that is concept, transaction. So until unless completion of one transaction, another transaction won't disturb, or it won't execute it. So that is called ACID transaction. So this is a basic in SQL Server. So same approach, same methodology, or same functionality supporting in Azure Lakehouse, using Azure, particularly Azure data lake concepts. And yeah, I explained previously, like if the table the using this, you can maintain the data version, and the time travel as well we can able to perform. And yeah, it is supporting batch as well as streaming data. So as we already know, like a batch is nothing but like a batch by page data insert or data process, and the streaming is continuous process. So both is supporting in data lake concept, data lake concepts. And the standard formats and the interoperability. The underlying data of data type is stored in Percute format, which is commonly used to data lake injection process or pipeline. Additionally, you can use SQL Analytics endpoint for the Microsoft Fabric Lakers to query data table in SQL. Okay, so it's nothing but, so the data storing is a Percute file. So the Percute file you can able to read using data factory by default. Using, if you want to ingest the one table to another table, you can read the Percute file directly. Then it will convert as a normal data. Then you can insert into another table. So that's what it's supporting. Standard format is supporting in the data lake. So always it's the data, like the behind the scene. Once you created the table, once you insert the data into the table or store the data into the table, the backend, the data will store as a Percute file. That's what they're trying to highlight here. And the next one is they are highlighting how to create the table. So when you create the table in Microsoft Azure, the data is given to the meta store and for the lakehouse. So mainly when you create the table, so we need to specify the metadata. That means like what is the data, what is the attributes, and what is the type of the attributes, and then it's needed what kind of format the data, and then you need the header to be created for particular file, and then which place the data need to be stored. So those are the information we will create. So in this example, what they are doing here, say they just reading one CSV file, and then they are writing as a delta save as a my table. So what will happen? This table save as a my table with the delta lake concepts. So whenever this kind of table, what will happen? If you drop this my table, it will get both data as well as table structure will get deleted. So this is the one way of creating delta table. So there is a one optimized way is there. I will tell you in the going forward, or maybe in the town it will be there. So this is the external table. So managed which external table. So the previously it's created a normal table like managed table. So here in the down they mentioned the external table. So here what they are doing, writing the table as a delta format, and then they are mentioning as a table, and then they are mentioning the particular path. So what they are trying to here they are trying to use here, they are using this path properties as well as save as a table properties, and then format. So the format will be delta, and the table name will be my external table, but the path will be my external uh, files, my external path. So why they are mentioning this one? So this is the external table. If I suppose in the if for example in the Microsoft Azure Fabric level, Apache, using Apache Spark, you will create the delta lake concept. You will create the first table database, then inside the database you will create the table. Okay, so the table will store on the table metadata will store on Databricks. You can consider as a front end metadata part, and the table will store on data will be stored on the storage layer backend. So if you are creating external table, for suppose if you are trapping this table, only the metadata will get deleted. But whatever the data will be there, right? Everything will be backend. Everything will be available in files until unless you are manually deleting these files. That's what external type concepts. So I will create the table and drop the table. You will understand what's happening. But in the previous example, what they are highlighted here, if they mention as a only table name and then format delta. So if you drop the table, then automatically this data will get deleted. Table structure also will deleted. But if you drop this table, you will get the table will get deleted. That means like metadata will deleted, but this the data will be available in this storage. If you want to restore this file path to some other table, then you can restore it. That's a functionality in the external table. Yeah, this is what they're mentioning. So this file path will contain your delta lake log table as well as circuit data, circuit file data. And then mm, so you can so this is the APFS location. So APFS is a storage location. This is like the latest data lake concept, APFS storage location. Previously on the storage they used what we call SFTP location. Yeah, SFTP in the I think Gen 1 data lake storage level. In the Gen 2 onwards, it's supporting ABFS location. So using ABFS location, you can mention the full path of the storage, and then URL. Then you can create that. So this way also you can create the external table. So creating table metadata. Yeah. So as I explained previously, so we can specify the table name, column name, and then what is the data type. So this is a like you can create the metadata, then you can use this table to store your data. Okay, so we are creating the create table. So that means like we can specify our table structure, then insert the data into your table. So in the previous examples, like the previous some Python codes what they highlighted, whatever your file have the getters, it will store as a table columns. But here what they are mentioning, we can create the table structure, then you can store your data. So if you want to increase the column, you can increase. If you want to implement your business logic, and then like for example, you will read 10 column from your source file, then you will add your business logic to build another 2 3 columns or another 100 columns. Then your destination table will show you are going to insert only like uh, another 50 columns. So you can create 50 columns of the table, and whatever the column you need from your previous business logic and derived columns, you can insert that to those derived column. So for that purpose, you can specify your table structure explicitly, and then use that table into your uh, no, uh, notebook level. Yeah, then they are mentioning the saving data into delta format. So to do that, you need to mention as a delta path. So this they are using delta path as a variable, and then they are passing as a save as delta path, and then they are mentioning as a file. Okay, so what they're trying to say here, they created the table structure, sales order, and then that is stored in this location. So if you save the data into this location as a delta, then automatically the table get loaded. That's what they're highlighting. So this is also one of the way to insert the data. So yeah, there are we can implement the mode. We can append mode or overwrite mode, or yeah, there are mainly we frequently use overwrite and append mode. So if you are going to perform only incremental data process, then you can go with append. If you are going to always overwrite the data, you can mention as a overwrite. Okay, so this is what they are explaining as a understanding to create the table. Work with next one is work with the delta tables in Spark. Okay, So using SQL Spark, the most common way to work with data intelligence, we're using SQL Spark SQL. You can embed SQL statement other languages as PySpark Scala by using SQL Spark SQL as a library. For example, the following could insert a row into product. Yeah. So what they are trying to say, you can use plain notebook. The notebook will be SQL notebook. If you are mentioning the Python notebook, then you need to use magic command as SQL. Then you can write your own SQL queries like this. Or if you want to do Python notebook, if you can create the Python notebook, and then you can use Spark.SQL context. Then you can write your own setup query. So this is a Python way, Python format. So you can use Scala or Java as well to write the SQL query with the different formats. Okay. So using the Delta API, when you want to work with the Delta files rather than catalog file tables, it may be simpler to use Delta API. You can create an instance of Delta labels from folder location containing a file in Delta format and then use the API to modify the data in tables. So from Delta tables import by Spark function import, create a data table object. Update the table. Yeah. So they are using Delta API. So using that API, you can write your SQL query this way. So pretty much very rare case people use. Mostly people use Python or Scala or SQL format to update the table or insert the table or maintain the tables. Yeah, use the time travel to work with the table version. So simple. You need to using describe command. You can describe the table, and then you can see the version of the tables and what is happened in this table. So the I think sometimes before I explained what they are doing in the version control. So what they are doing here, the first version, the 0 version, the table got created. The version 1 level, they are writing some data. The version 2 level, they update the table. If they want to revert this table, this version, they can revert. Okay, they can revert, and then it will get the actual structure. After writing, they want to revert this version, they can revert. We can revert. That's what it's supporting version as well. So to do that, how to describe the history like this? The version name, you can see my files describe the history. My files are tables. My table, you can retrieve the table. Yeah, the command they mention is, and then they mention is version of sub 0. So they are trying to revert that. They are trying to read this using data frame. They are trying to read this version of the table and load into delta path. That's what they are trying. Yeah, we can use option, and we can use time. As per the time also we can revert the data. So that's what they're maintaining. That's what they're explaining. How to use the version control version control functionality in the Delta Lake tables. So streaming, yeah, this is also one of the important feature in Delta Lake concept. So streaming process is nothing but continuous integration or continuous reading or writing process. So that's what it is, supporting. The Spark Delta Lake concepts are supporting this as well. And we need to use Spark structure streaming API. So let's go to the example. Here what they are doing, yeah, they are importing SQL type and SQL functions, and then stream TF, read delta label, ignore change true, load to file. So they are creating stream data frame. There they are mentioning a spark read stream format. So this is what this property is mandatory. So the that case from this location, whenever the data is writing, any action is happening, automatically it will get reading. So ignore change to true. So whenever when using delta type as a streaming source, only append operation can be included in the stream. Data modification will cause an error unless you specify the ignore change or ignore deletion option. So only if you are not mentioning ignore change and true in these properties, then what will happen? Your table will get fail until unless only append happen. For example, this location your table data stored, only storage is happening, only insert happening, then your table this streaming will work. If you are doing any update or any changes to this location in the table or data, if you are not mentioning this ignore changes equal to as a true, then your streaming won't work. That's what they're mentioning. So we have to always mention this is the mandatory option. Okay. Yeah, that's what they're mentioning. We have to ignore change and ignore delete as so whenever deleting, or if you want to do any change, if you want to avoid any changes, then you need to mention this. So for simple, you have one table. In that table, always insert only going to happen. Then you don't need to specify this. Okay, but uh, your table going to get changed sometime, or your table going to delete some data. So those kind of situation, you need to read for streaming purpose. Then you should specify this option. Okay. So using the delta table as a streaming string sync. Okay. So what we are doing here, what they are doing, they are reading they are mentioning the input path, and then they are creating the structure type. That means like they are creating the table structure here, and then they are using this data frame and using data from input path. So they are going to read the data from this place, and then explicitly mention that field name. They are specifying the schema here, and then they are writing into target path, and also they are creating the checkpoint. Okay, so the checkpoint is one of the important option or properties. The checkpoint option is used to write checkpoint file that track the state of the stream processing. This file enable you to recover from failure at the point where stream process is left off. So if you enable the checkpoint, if you created the checkpoint for your table, so whenever you will end up with any failure or anything, any changes, any error in the table, so from that you can recover the checkpoint from whatever the successful checkpoint. From there to next all remaining data or level of the data you can recover or insert or read again for your streaming. So for that purpose, checkpoint location, I think we can see as an example, you will understand, people know, you can understand it easily. So same things they are mentioning as how to create the table using delta and select a way from the table. Okay, they are creating the table using delta and location by this this location, and then they are reading the field, because these two attribute available as part of this file location. Okay, so always there we need to stop the delta streamed out, stop. That's what they highlighted. Okay, so I think they given the exercises. Let's go to the exercise, so that case you can understand easily. So okay, so apologies for yeah. So here they given one of the, they are explaining the same things. We need to create the workspace. Already I created the workspace and I have uploaded the file as well. The lakehouse already we created, and I uploaded the product.csv, and then yeah, this I can see now. As of now in my workspace this file is there. So explore the data in data frame. So here what we are going to do, we are going to read the data using the data frame, and then we are writing as a delta frame. Okay, delta lake. Just I'm taking this, go to the demo. So if you see here, I have my file here, and the folder is there, and the file also uploaded here. I'm going to create a new notebook that will be demo delta lake. Okay, creating this. So what I'm doing here, under files I have the product folder. Under that I have the product CSV. I'm going to read this and display. Now I'm going to read this and then display that data frame. Let's run this query. So moreover, in the document level, we are just seeing the very basic level examples. If you want to explore your own, you can put whatever the complex query is and you can test it out. Welcome to the network driving result for the now for data frame seems to be there are error. That return value. What is the actual error? Yeah, the path is not found. Okay, so what I have to do, I have to wait. Okay, so what I have to do, I think I need to mention the path location. Let me check it is coming or not. Let me copy the API path. So I'm going to specify products, product, then products.csv. Load. Yeah, so let me rerun this. So we have mentioned the proper API bus location of that the file location. So it is reading. Let's see what is happening. So meantime we can add, so this is what. So we have mentioned the proper API bus location of that particular file. So that gets is reading, and then we are displaying the it's okay. So here this is the data we have. We have product ID, product name, category, and list price. So these are all the. So what we did, like we just created the data frame and read that file. Okay. Now the next example. So we're gonna create as a delta table. I can show that. So what will happen? It will the data frame already we created here. We have displayed. So this will create as a delta table. I will show that. If you run this, it will get created as a table, as a data table, and then the file will be there. So let's refresh the table. Okay, so manage the table got created, and then you can see logs as well, and then whatever the data is there in the top. So it got created with the log as well as the data. So we didn't mention any particular path, so that is why it's created like this, and we can see the data as well, like a different location, different folder we are unable to see now. Okay, so now the next level we may create one more table. Wait a minute. Yeah, so here what we are mentioning, we are specifying the external path. So what will happen, you will get created table one place, and then yeah, here you will get create a table get created here, and then you can see the location another file also will be there. So here we API bus path location, right? So API bus path already we have here. So let me go here. So I don't want to use okay, let me use this location under product. Yeah, so this is my API bus location, and then yeah. So save as table. Yeah, so what we are doing here, we have we specified the external path location, API location, and then table name is delta table format, and external table product. Okay, so I'm going to run this. So what will happen, you will get the table will create one place, and then folder will get created another place. So I'm just creating this table, and then this is my table name. So what I'm going to do, I'm going to drop percentage SQL drop table name. Okay, it got created. So let me refresh these tables, and then refresh the file path as well. See here, so the external product table got created here. Here we have create, like it got created another folder as well. In that folder we have the delta lake, delta log as well as part. So what will happen, this will maintain the log for the table, and this will maintain the data of the table. So that's what this is, this is one of the good kind of advanced technology we can say. And if I drop this external table, this table only will get dropped, but this folder will be there. That means like the data will be available here only. It won't get deleted until unless you will right click delete. Okay, manually delete. If I suppose if managed product, right, this table we created in the top as a managed product. If I drop this table, the table as well as whatever the data is available in this table, everything will get deleted. Okay, so let me explain it. Let me run this, let me drop this table. I will show what is happening. So I just dropping the external table. So if I refresh this table now, table list, my external table will gone. Okay, will be gone. So it gone now. So but if I refresh this path location, the external product, so the table data will be there, data and log will be always there. So whenever we need, we can revert this, and we can create the another table and find out this particular location. But the column name should be same whatever we inserted here, then automatically you can recover the table. So this functionality, that's what the external table concept. Okay, so now if I suppose if I delete if I drop this table, I can't see anything. The table will drop, and then the data also will get dropped because we didn't mention any external path to store the data or log files. So everything will be there here only. Okay. So now if I refresh, you can see the table are gone, and related to the data also gone. So now I'm going to recreate the same tables because I need to use for my next level of the code. So I'm just showing as a sample purpose what is that now, why we are creating external table concept. So if you see here, if I drop this table, what is happening? If I try to use the same table to insert the data again, it is saying like already the location have the data. So either you need to drop this table or you need to recreate the table. We need to create the table without inserting the data. Okay. So we will in the next session, like in the next example, we can see what is the difference between why this error is coming, how to avoid this. Okay. So as of now, I'm just changing. I'm putting one more yes, and I'm storing this file as another file. Okay. Yeah. Another folder is created, which is which products is. Okay. Let's go to the next example. Yeah, this is the way we created the table, and we we created the normal delta table and then external data table. So we see like what is the difference between these two. Yeah, now we are going to see versions. Okay, so let's go to this. Yeah. So let's go to let's describe the table. If I describe the table, what will happen? So it will show the table structure. Okay, describe format. So this table have this all these columns, and these are all tables. These are all the commands is null. Okay, it will show the table structure. This command. So now, yeah, we already dropped this table, and then yeah. So previously, it's gave the error, right? So there is a let me drop this table again. Dropping this table. Okay. External product is there. So the another table we created, right? Product managed product. So this table got created already. We dropped now. This also we dropped now. So we can see here the data both the tables got deleted, dropped again, and then if you see the folder location, the data will be there because we specified the external version, external path for the for the data and the log. So this is already it won't get created. It won't get dropped. So now the next example. So I want to create another table, but I need to use the previous location which is already available. Okay, so the previous query we saw some error, right? So when I do this way, I got error saying that the folder location is not empty. It is not allowed us to use that table. So what we are trying to do, the same external location, we are trying to recreate the table with this data frame. Whatever the data, we are trying to insert the data to that particular location. Again, we are recreating the table. So this way we cannot recreate the table. Like we cannot create the table to use previous storage location. Okay. So to avoid that, this is another way. So this way you can create. So you can create the table as a product using delta. Then you can specify the location. So what will happen if you run this? This product table will get created based on your external this location. Okay, this location, whatever the file is there. Okay. So the product table is there, but the data showing here. Yeah, the data whatever is here, it will show in the table. It will be whatever the data is available in this location. That means like the previous table which we deleted, right? In that table, whatever the data is there, that will populate it to this product table. Let's go here and just to query this table and verify. Let's see. Okay, so something corrupted. Okay, what is the reason? The reason behind. Let me delete this table. The path we mentioned, right? We didn't mention proper API location. That's the issue. So let me copy this location. So what I'm going to do, I'm going to pass proper API location to create this table. I'm just running this table. Now the table will get created. Let's see. So I can see the data whatever part of the previous data frame. Product ID, product name, category, list price. So the same whatever this data frame have previously, the data we have in previous data frame, right? So this we created this we created this data frame. After that we created the delta table, normal table, and inserted, and then we created the external table. We specified the external path location and inserted. Okay, so again we dropped this table and recreating the table to point at that location. Then I am selecting this product. So whatever the data is part of this file path, it's coming to this table. Okay, so this is for sample purpose created. I'm just deleting that. Yeah, this is no, that's all. So we can able to using delta table. You can create the table. You can, if you created the external table, then you can drop the table, but you automatically don't drop the data. So you can able to reuse the data for some other table as well. Like you can recreate the table with the pointer to that location. In that case, you can reuse the data. That means like whatever the table you got dropped, you can reuse the data, that dropped table data. So another functionality, update product. So what we are doing now, so we are just going to update the data because we need to see the version maintenance. So the same table I am updating this data now. List queries. Just I'm just adding some calculations based only for these categories. So 32 rows got affected. So now I'm going to see the versions of that table. So I'm just description table. Describe the table. So what will happen? It will give the what are all the versions for this table. So there are two versions for this table. Version 0 and version 1. Version 1 will be create table, another one is update table. So just now we updated in the previous query. So it is capture of the, like it's captured both the version of the table. Okay, inserted and created and then updated. Now let's go to another example. Yeah, so now what we are going to do, like before update, whatever the data is there, so we can read that and verify the data. Okay, so this is a data path. So what I'm going to do, okay, I'm going to copy this delta path, like APPS path, the table location. I'm going to, so in the table we have two versions. One is created version and another one is updated version after created. So what I'm going to do now, I'm going to read version 0 and again going to load this location, and then I'm going to display this data frame. So that means without update query, whatever the data previously is there, that will show. That means like we are reverting the version 0 to this table. Okay, that is a, yeah. So for example, you have multiple versions for this table. So whatever the version you want to revert, you can mention the version number, then it will get reverted. Or if you can mention the particular timing, like whatever the timing, that using that also you can able to see timestamp also you can use. You can revert the data, or you can read this particular version and see what is the difference between this version and this version as well. Let's go to next. Yeah, next concept is streaming. So let's create a streaming table. Okay, let's do this example. Let's go here. Yeah, let me take the input path. So input path is nothing like my table external location where the data is there, where the data will load. Okay, I'm just giving this. So I can mention this. I don't need to mention the table name. I can mention the okay. So in this location, whatever the data is there, I'm going to read. And then I'm creating the table structure for the schema, and then I'm going to read that file from this location and creating this table, streaming table, and I'm writing just some conditions, write some event data to the folder, device one status. Okay, okay. So whenever this kind of all these actions are happening, so my table will get streaming read. That's what we are specifying here. Let me run this query. Let's see what's happened. Yeah, so the streaming table got created now, data.txt twice. So most probably we will get another. Yeah, so here, yeah, another data.txt is got created because we are creating this from this location. We are creating another txt file. So whenever this file got updated, then your streaming data table will get no, run. I mean, like the file with the data.txt file get updated or inserted or deleted, then the streaming table will get run. Like it will read the data. Okay. So the new code are, yeah, write a schema delta table. So we are adding checkpoint as well, and then the okay. to write another code. So what we are going to do, tables, and then I can mention as IO device data. Hold on. So do we have IO device data streaming table already? Let me refresh this table. Okay. Right. Okay. So I'm going to read that particular tables and then write into streaming delta path. Okay. Streaming table delta stream delta path. Okay. So let's run this. What is happening? Yeah, it got created. So I have created the checkpoint, and then files, under files I can see delta and then checkpoint. Yeah, so the checkpoint got created, and then this location, and then I'm reading the IO device data table location. Okay, but we don't have anything IO device. Maybe it could it will give the error. We need to specify proper IP bus location of the table. Okay, now let's run this. Select star from this. Yeah, maybe it will get error because we didn't specify the proper location, IP bus location. Let's run this. Oh man. Wait. Got it. So what has happened? So we created the table device under status as a streaming table in the top, and it is stored as a text data.text as a as part of this external product location. So that table like that file we are reading and writing as a streaming table in the top. So we had mentioned the checkpoint as well. Okay, we are adding some more data to this file. Let's see. In this example, we are adding some more data to this file. So we added some more data, and then now we can see this output of this table. Let's see. Yeah, so it got error. That's the data we inserted recently, the top. So everything got populated. So we once we created the streaming table. So whenever we are inserting any data to this table, we no need to insert again to this table. Automatically it will take care from the streaming file, whatever we mention as a more data.txt. See this much of data. So we are delta stream stop. So we need to, I think we no need this stream table. So we just stop the streaming. Okay, so that case otherwise it will continuously run in the background. So simple. So it is Delta Lake supporting all Spark concepts to maintain the data as a relational database. It is supporting versions, and if whatever the version you want to revert, you can revert also whenever you need it. And other than that, uh, you can use streaming purpose as well. Delta Lake tables. Once you create a streaming structure, then automatically it will get read for your table. And when you create the table, you can blindly create the table as well, and you can create a say external table as well. So if you create the without specifying the external path, if you create the table, whenever you are dropping the table, it will get dropped. For suppose if you are creating the table with the external path location, even if you drop the table, the data will be stay there. You can reuse the table. And other than that, it will maintain the version table, so version history. So whenever you want to maintain the, whenever you want to revert, or you want to compare the previous versions of the data, you can able to perform. So this is what mainly data lake concept. Simple like batch process, streaming process, and then external table concept, and data lake plain without external like normal internal data lake concept, and then how to maintain the versions. So these are the important features supporting in data lake concept in Azure Fabric. So this is what we plan to cover today. So in the previous session, I think we can go for data factory pipeline. So that will, the previous session we can cover data factory, how to use that, how to create the data factory in Microsoft Fabric, and how to do the ingestion process. So that will be more interesting. Let's see in the previous session. Thank you, everyone.